The simple idea of a matrix is that assuming you have the days of the week, right? So the days of the week on one side here, and then let's say you are a student. So imagine on Monday you choose to consume like gashit, right? So maybe gashit, gari and shito is okay. In some cases, gari and shito. Let's say two ladders, right? Just for an understanding purpose, so two ladders, or maybe two balls of gari and then shito, and then on that same Monday, maybe that this one should be in the afternoon, right? So on that same Monday, maybe you are going for a rice, just a plate of a rice, right? So okay, what happens on Tuesday, right? So on Tuesday here, it can be a different item. Is that okay? So anything that you can take of, let's say you took maybe two, and maybe in the evening you decided to take nothing, right? So the concept here is that if this thing happens, then you arrange it in somewhat row and columns. So what I mean by rows and columns, so you have rows here and then as well as columns, right? So the rows goes like this, right? The rows goes from left to right. Is that okay? So it's from left row. So from left to right, right? So from left to right. Is that okay? So it's from left to right, and then the columns goes the other way around, from top to down or down to top. Is that okay? Now that is it. This is very very important. So you have to pay close attention to these two words here, right? So row goes like this from left to right, and then the columns go from top to down. Now from here you can see that if I want to redraw this thing, this two can be 2 1 4 and then 0, right? This is something that we have. Sometimes you use a curly bracket here to represent the matrix. Is that okay? So if this is the case, if I say row goes from our left to right and then top to down, so this here from here to here is what, one row, and then this here is what, two rows, right? So you say 2 by what, by 2. How many columns do you have here? One column here and then another column here. That's 2. So 2 by 2. So anytime you hear the word 2 by 2 matrix, meaning that you have two rows here and then what, two columns, right? Once it goes beyond that, that is the same thing. So the first number here goes for the rows, and then the second one goes for what, the column. Is that okay? So what about 3 by 3, right? What about 2 by what, 3 by 3, and then 2 by 3, meaning that you have two rows and what, three columns. So okay, that's very very simple. Now how do you multiply, how do you subtract, and then how do you add and other stuff, just like in the real number? So if I say 4 by 1, 4 multiplied by 1 is equal to 4, just like multiplication. But in matrix you have a different way of multiplying and then subtracting. Then our other stuff relating to a matrix will be what, embedded in what, our next lesson. Multiplication in of matrices is something crucial. You have to pay a close attention to, right? Not that it's difficult, but it's just a simple way, just like a step-by-step way of doing that. And now in multiplying, so this is just a very simple scenario that I'm having. I have the matrix A, right? Normally we use a capital letter to represent the matrix. So I have A and B here. These are the matrices that we have. Since now you have a clear understanding of what a matrix may look like, right? So these two things are just like a 2 by 2 matrix here, and there is also another 2 by 2 matrix. Now we want to multiply, right? So meaning that we are going to multiply the A by B. Is that okay? So the way of multiplying is that what I normally do is that, look at this diagram here, right? So this diagram, this very simple diagram, I don't know how you want to call it. This can be L upside down, right? So L upside down, right? So look at the direction. So what it means is that once you have this drawing, that this thing can guide you to know exactly what you are doing or how to multiply what in what of matrices. Now how do you do that? What I mean by that is that we are going to pick the first line here, right? So this line here is going to multiply things that is going down like this. Is that okay? So this line here, this line which is -2 and a 1, are going to multiply the 1 here and the -1 and -2. That's why I say this goes like this and then you come down. Okay, so how do you multiply? So you pick this -2 here, is going to multiply the -1 in the first place, right? And then plus, remember there's a plus here, so plus, right? So plus what? And then 1 here is going to multiply the 2, right? So the -1 multiplying the -1 here, and then plus what, into one bracket, since we are dealing with a negative, and then 1 multiplied by what, the 2 here, right? Okay, once you are done with that, you leave a space. So that's just a 2 by 2 matrix. Is that okay? So we are done with the first part here. So second one is that the same scenario, the same number here, go to multiply the 1 at the down. Is that okay? So -2 multiplying what, 0 here, so and then 1 multiplied by what, the 3, plus or 1 multiplied by the 3. Is that okay? So this is a very simple method here. Now once you are done, the same thing applies to the down one. So the down here will be what, the 4 here multiplied by what, negative 1 here, and then plus or 2 multiplied by what, the 2, so on one side, and then the second one, then the same thing you use to multiply the second aspect. So if you are done, then you know how to add and subtract and then multiply any other things already, right? Okay, so here if you perform this calculation here should give you 2 plus, so that should be 4 here, and then the same applies to the rest of the aspect. So what I get at the end is 4, 3, and then 0, and then 6, right? Addition and subtraction is very what, simple in what, I may use the word simple, right? So it's simple in what, of a matrices, right? Says that this is a very two nice matrices that we are having, right? So if it is a two nice, we want to add the two matrices, right? So I'm calling the first one P and then the second one Q, right? So you want to add them. The key to addition is that look at where this guy is. This is the first person here, right? Can you see this guy is locating at maybe row 1 and then column 1, right? So the position of this guy is row 1. You agree with me that this is row 1 and then column 1. So this guy is here. Okay, so if you want to add here that this guy must be added to your opponent, your partner here, right? So if you are located in this house, if you want to add a 2, you have to add this guy to what, this one here. You can never add this one to this, neither any other portion. Is that okay? So neither any other portion. So the only way you can add it is that wherever you are, you have to go and locate your partner in the next house. Right? So this 0 here will be added to the negative one. So 0 plus or negative 1. And then this 1 here will also be added to the 1 here. Look at the position. The position matters here. Right? So 1 here will be added to the 0. So 1 plus 0. The same applies to these two people. So 2 plus what? 5 here, and then 3 plus what? Plus 4. That should give us so if you add these two people here, everything here, you should have negative 1, 1, and then 7, and then 7. The same applies to the subtraction. So if you want to subtract here, you have to subtract this guy with this and then this guy with that one. You can never interchange them. Is that okay? That is a very key and a simple way of adding and subtracting of matrices, right? So if you have a question, let me hear from you in the comments below. So this is another word on the matrix, that is determinants, right? The word here is determinants. So let's just assume that you want to determine the strength of someone, right? So you want to determine the strength of anything that you can think of. So the word is here is determinant. So how to determine what? Maybe let's say determinants of what a matrix here is that this is a matrix, right? This is a very simple matrix. That's the 2 by 2 matrix. So there's a way of calculating that anytime they ask to find the determinants of this matrix, maybe this is a 2 by 2 matrix. It can be a 3 by 3, which we are going to see later on from this lesson. So the determinant, this is the symbol that we use to represent the determinant, this bar. So we use this 2 bar here, right? So determinant of P, so whatever that may be. So this is what we are going to use, right? These two lines here represent our determinant. It donates our determinant, right? Anyway, you see these 2 bars here, then the name of the matrix is within it. That was what we call the determinant. That is equal to. So this is how you calculate what the determinant of the 2 by 2 matrix. That is what this guy multiplied by this. Look at the line, right? So this guy multiplied by that. So this line here, so this 0, whatever is here, multiplied by the 3. So the diagonal, right? So the diagonal goes like this. So 0 multiplied by 3. That's 0. 0 multiplied by 3, and then into one bracket, and then minus, right? The sign here is minus, right? Neither addition or multiplication. So minus, then this one multiplied by this. So that is 1 multiplied by 2, right? So here is going to be what, this will be 0, and then minus this one, that should be what, the answer should be 2. So the answer is what, going to be what, negative 2, right? So this is the determinant of this matrix. Is that okay? So diagonal, this one multiplied by this, minus or this one multiplied by this. So what about this? If you also to find, let's call this one A. So the determinants of A here is going to be this one multiplied by this. That should give you what, a negative 4, right? So negative 4 minus, always there's a minus irrespective of what we are going to get here. So this one multiplied by that, that should be 2. So if you subtract it, so then there you are going to have a negative 6. Okay, so these are how you find the determinants of a 2 by 2 matrix. Maybe some cases you can have a variable here, they can take this one out, right? they can take this one out, and then they ask you to find the determinants of the matrix. Don't be panic. All right, we are going to do is this letter multiplied by this. That will give you what? 4k, right? 4k, and then minus this multiplied by that one, that should give you 2. Maybe in some cases you'll be giving the total determinants, right? So I will send you some questions to try your hands on this concerning the determinants and the multiplication, as well as the adjacencies of what a matrix, and see how best you can do your portion. So finding the inverse of what a matrix. So let's say this is a very simple scenario here. Now, if you have what, let's say you and your friend, you go to any restaurant to buy some what food items. So here we are using yam and what and the chicken, right? So maybe you are going for maybe some $3 of a yam here, right? So that's the day one, and then maybe $5 of a chicken, just for understanding purpose, right? So maybe your friend John, right? Your friend by name John, just going for $1, right? So just $1 for this yam, and then maybe $2 for the chicken, right? So in metrics form, this is how it should look like. Is that okay? So if you bring this thing down, this is the numbers that we are having. In case you have a negative amount, maybe you can even think that that person is going to buy this thing on what, a credit, right? So maybe let's say if here was -5, then it means that the person bought it on what, on a negative, right? Okay, now this is the symbol. So if you want to find the inverse, of course this is a 2 by 2 matrix, right? So the idea is that we have 2 rows here. So from left to right is the row, right? From left to right is the row, and then from top to down is the column. So from here to here, so 1 row, and then this will be what, the second row, and then top to down like this. That is what the columns, right? Okay, so if that is the case, so you have 2 rows and then by what, 2 columns. So this is what, a 2 by 2 matrix. If you want to find the inverse, so what it means is that if you people are buying this thing as well, the food stuff that you want to enjoy, right? So the food that you want to enjoy here, and then let's say the inverse here is that if you go like this is your first one. So you go like this, you want the food items, right? So the food items here, is that okay? And then the inverse is that you have to pay an amount of money, right? So you have to pay an amount of money. That is just a simple scenario for the inverse. So an amount of money that you are paying for the food that you are buying, that is what we can call, maybe let's say, inverse. Is that okay? Now if you get a, you have to purchase your items for their machine to determine how much you have to pay at the end of the day. So this is the machine that is going to tell us that this is a particular amount of money you have to pay for the items that you are buying. So the definition is that we have a 1. So this notation stands for inverse, right? This is just a symbol of inverse. Is that okay? So here we are naming that M, the matrix. We are naming the matrices of M, right? So whatever matrices that we are dealing with, that should be the symbol of that inverse here. So 1 over the determinant, so multiplied by the adjoint. So the key here is that you have to understand or master the concept of what these two people, right? So in mathematics, all you have to know is that if you are giving any definition, you just know where they are coming from, what exactly what they mean. So the determinant here is that uh here's the determinant. Here's the symbols of the determinant, right? So you have a double by here, and then the matrices within, and then this is, of course, this is a 2 by 2 matrix. If you want to know the 3 by 3 and then so on and so forth, make sure that you subscribe to the channel for more videos like this, right? So for 2 by 2, you just need to multiply this one with this, right? So the 3 multiplied by what, the 2, we call it a diagonal, right? So this one multiplied by this, that is what, 3 multiplied by 2, right? Minus what, this one multiplied by this. Is that okay? That is for a 2 by 2 matrix. So 5 multiplied by 1. So 3 multiplied by 3, that should be 6, and then this one multiplied by that should be 5. So the answer is 1. So the determinants of this matrix is just 1. So from the definition that we are having, or from the formula here, this is the key, right? So this is the machine that is going to determine the inverse. So now that we know the determinant, you have to look for the what, the adjoint. So the meaning of the adjoint of the 2 by 2 matrices is that this is the matrix that we are dealing with, right? So this is the matrix that we are dealing with, right? This is the matrix. So the meaning of the adjoint here is that you have to interchange this one and this, right? So the vice versa, wherever you are, let this guy comes here and then this one goes here. Is that okay? So here, that's the first step of a 2 by 2 adjoint. So we are interchanging. So initially 3 was here, 2 was here, so these people interchange. So here we are having 2 here and then 3 here. So obviously this is the matrix that we are having. Initially we have 3 here and the 2 here, so we are looking for the adjoint, right? So that's just a simple definition. So you interchange these two people, and then these two guys, you don't do anything to them. The only thing that you are going to do is to add a negative to that, right? This is just a definition. So okay, if I tell you that I use this white marker board to write on this whiteboard here, it's possible, right? That's the definition. You just have to obey. So this is just a definition here. Is that okay? So that's the machine that can help us to determine the adjoint. So in all, after interchanging these two people, and then you take a negative of these two. Remember, we don't interchange these two people wherever they are. That's how they are supposed to be based on this matrix that we are having here. This is one matrix. 5 was here, 1 was here. The only thing that we interchange is these two people, and then these people here we take a negative of them. So now that we have the determinants and what and the adjoint here, we are free to just find the inverse of the m here. So the only thing that we are doing here, we are just replacing, right? So 1 over the determinant, so 1 over 1 and multiply by the adjoint. So this is the adjoint, right? So here, if you multiply this 1 over 1, will just give us what 1, right? So the answer is 1. So 1 multiplied by what this matrix here, that is negative 5, negative 1, and then 3, it will still be what the same matrix, right? So 2, negative 3, 1, and then 3, right? So that is what this is the inverse, right? So this is the inverse, this is the reverse, this is the amount that you people are supposed to pay at the end of your items.